In shielded metal arc welding, electric voltage is applied between the electrode and the workpiece to create an arc. With a temperature between 4 and 5,000 degrees centigrade, this arc melts the electrode and workpiece to create the weld. The electrode melts and is transferred into the weld pool as some of the workpiece metal melts as well. As the weld pool solidifies, it forms the weld beads and the slag. The coating on the electrode makes it easy to initiate the arc. It also creates a more stable arc during welding, and it forms slag that covers the weld pool and forms a good bead shape. The coating also forms carbon dioxide that protects the weld from air. The electrodes used for shielded metal arc welding consist of a core wire covered with coating flux. For electrodes used to weld carbon steel, the core is made of mild steel. The coating makes it easier to control the electrode's weld pool, and it improves the mechanical properties of the weld. The coating typically is made from a mineral or organic material or metal powder together with a viscous liquid known as water glass. The coating is applied onto the surface of the core wire and dried until hard. The materials chosen for the coating flux greatly affect the operating characteristics of the electrode and the quality of the weld. Let's look now at how to do the welding. First, hold your hand vertically and grip the holder in the crook between your thumb and forefinger. Clasp the electrode in the holder at a right angle. Adjust your position so that your shoulders are parallel to the welding line and the workpiece is directly in front of you. Then bend your arms slightly. Set the welding current according to the type and size of electrode, the thickness of the base metal, and the position of the welding. One method for striking the arc is called tapping. Hit the electrode lightly against the workpiece surface and let it bounce back. Another method is called brushing. Scratch the end of the electrode along the workpiece for a short distance as though you were lighting a match. There are two techniques for moving the electrode. The first is called the stringer method. While keeping the length of the arc short and constant, move the electrode forward in a straight line. Keep your eye on the weld pool so that the electrode tip is always the same distance from the weld pool. The second technique is called weaving. Again, keep the length of the arc constant, but this time zigzag the electrode back and forth as you move it forward. The pitch of the weaving should be about the same as the diameter of the electrode's core wire. Keep the arc short and move the electrode equal distances to the left and right. The total width covered by the electrode should be no more than 3 times the diameter of the electrode's core wire. By limiting the electrode's motion on both sides, you can create a bead of the required width. You can tell whether the arc is the right length from the sound it makes. If the arc is too long, it will make a low hissing sound. As you make the arc shorter, you'll hear a crackling sound. This crackling indicates that the arc is the right length. Make sure that you continue to hear this sound as you move the electrode.